Hi, today we're going to take a look at solving logarithmic equations. I know you guys have been looking so forward to this. You've heard about logarithms for a long time, but today we're just going to take a look at the basics, the nitty-gritty. So first of all, you've got a log base a of x equals c. We need to keep in mind that your base here has to be greater than 0, and it cannot equal 1. So you can have positive fractions and any positive numbers greater than 1, which also means that this number here is going to have to be positive, and that's based on the definition, which I'll show you here in a second. So what do I need to know? First of all, the definition of a logarithm. I want you to think exponents. Logarithms represent exponents. Now let me show you how. If we have the logarithm of base a of x equals c, notice I'm saying base a. Think of base of an exponent. If we take that base of a, we can take it to the power of c. Remember, logarithms represent exponents. So a to the power of c should equal what you're taking the log of, which in this case is x. So we're able to rewrite this logarithm equation as an exponent or possibly an exponential. A to the c equals x. This is going to help us to undo the logarithm using the definition. Also, if you see a logarithm and you do not see a base, it's understood to be base 10 since we work in the base 10 number system. And also, this is called a natural log. It's still a logarithm, but it's understood to have a base of e. So anytime you have an equation with e, you're going to use the natural log. You also need to know the exponent rules with like bases. When do you add exponents? When do you subtract? And also how to solve all the previous types of equations that we've done. Linear, quadratic, radicals, rationals. It depends on how your logarithm reduces. So let's review how the exponent properties that we've learned in the past affect the logarithm properties. Remember, if you have a like base and you're multiplying, we add exponents. So with logarithms, since they represent exponents, if you are multiplying with a single log, you can rewrite that as adding, remember, like adding two exponents. Likewise, if you have two logarithms and you want to write it as a single log, which is what we're going to be doing today, you can write it as a single logarithm, but instead of addition, you now have multiplication. So a single log of multiplication into two logs of addition, or two logs of addition into a single log of multiplication. Same thing works with division. When you divide like bases, we subtract exponents. So guess what we're going to do with a logarithm if we're taking the log of a fraction? Exactly. Logarithm of a fraction, which means division, can be rewritten as two logarithms using subtraction. Or if you have two logarithms that are being subtracted, we can rewrite it as a single logarithm in division. So if you remember the exponent properties here, and the fact that logarithms represent exponents, that's going to help you to remember this relationship, okay? And we're going to be going this way a lot today. Two logarithms into one, because remember we're trying to solve, which means we need to reduce that equation, whittle it down. The very last one, this one actually you're going to use in the next segment when we're solving exponentials, but it's very important, so I'm going to have you start this one. If you have a base and you're taking a power to a power, we multiply exponents. So if you have a logarithm that represents an exponent and it's also being taken to a power, we are allowed to rewrite it with the exponent in front and then have the logarithm base a of m here. So we are able to write it as multiplication, in essence, of two exponents, the exponent you had here and the logarithm that represents an exponent. So if you remember to move any exponents to the front, this is going to help you when we start solving exponential equations in the next segment. Let's take a look at this example. Log base 3 of x plus log base 3 of the binomial x plus 8 equals 2. Again, your goal is to whittle down the equation, get rid of any obstacles so we can get x equals a number. Well, the logarithm is definitely an obstacle, and we've got two of them. So remember, if they represent exponents, when do we add exponents? When we're multiplying like bases. So we can rewrite this as a single logarithm, okay? Rewrite as a single logarithm, and then multiply the items that we were taking the logarithm of. One thing I want to point out, what a lot of people want to do here, is they want to distribute this log, okay? And it's very common. You see something in front of parentheses, oh, I know how to distribute, I want to do it. You have to refrain from doing that. The reason is, log by itself is meaningless, okay? It's not a number. So you can't multiply it or distribute it like it's a number. I couldn't divide both sides by log of 3 to get rid of it because it's not a number. It's a function. You're taking the logarithm of something. It's always of something. So it has to have a number attached to it at all times. So you can't distribute, but you can combine into a single logarithm using the multiplication and addition properties. So now that we have it here, let's go ahead and simplify what's inside x squared plus 8x. But we still have that logarithm that we don't want. So we can use the definition to, in essence, undo that logarithm. So use the definition. We have a base 3 taken to the power of 2. That should equal what we're taking the log of. So let's rewrite it. 3 to the power of 2 equals the x squared plus 8x. Now we have a quadratic. So we can use either the quadratic formula or we can factor it. It happens to be factorable. So if we factor the right-hand side, we get x plus 9 times x minus 1. Set both of these factors equal to 0, and we would get x equals negative 9 and x equals 1. Don't party just yet. Remember, anytime we have an equation that has a restriction, a restricted domain, we have to check our answers. Logarithms, the bases have to be positive, which means any exponent I take it to is going to give me a positive number. So we can't take the logarithm of a negative number, which means this guy doesn't work. So check it, can't take the log of a negative number, so that x equals negative 9 doesn't work. So our only solution is x equals 1. And we can plug that into the original to make sure it does work. So now I want you to try. Here are 3 different equations to solve. Remember what the understood base is here, okay, base of e. Go ahead and pause the video, give it a shot. Remember, before you're right, you have to be wrong, and before you're wrong, you have to do it, okay? So practice. Go ahead and give it a shot, and then when you're ready to see the results, hit play again. Pause it. All right, let's now take a look at the logarithm examples that you did. So we want to get this logarithm by itself, so we're going to divide both sides by that coefficient of 2. Since 2 divided by 2 gives us the 1 logarithm that we're looking for. So that leaves us with log base 4 of x equaling 3. Now we can use the swirly-do definition. That's not the official definition, by the way, in case you're wondering, where the base of 4 taken to the power of 3 will equal x. So now we can rewrite it without the logarithm. So 4 cubed equals x. 4 cubed is 64, so 64 equals x is our solution. Okay, let's take a look at B. We've got log of x plus 6 minus log of x equals 2. Again, logarithms represent exponents. When do you subtract exponents? When you are dividing like bases. So we're going to change this to 1 logarithm and division x plus 6 over x, and it still equals 2. So we're still going to use the definition. Just remember, if you do not see a base, it's understood to be the common log or base 10. So if you need to write it there to give yourself a visual, go for it. So 10 to the power of 2 should equal this. So we have 10 squared equals x plus 6 over x. And this is when you start to wonder, am I doing it right? Because it looks a little complicated. But yes, you didn't end up with a linear or a quadratic. You got a rational. But that's okay. Keep going. We're going to clear this fraction by multiplying both sides by the x, by that denominator. So those two x's divide out. That leaves us with a 100x equals x plus 6. And then when you subtract the x from both sides, minus x, and we'll move it up here so we can see it a little bit better. That's going to give us a 99x equals 6. And again, some people even stopped here and went, well, I must have done something wrong, because look, when I divide by that 99, I get this weird answer, even if I simplify it. I get, let's see, 3 goes into both, what, 2 over 33? Well, that can't be right. And then people start erasing everything and start recreating math. Nobody promised that this was going to be pretty. It's algebra. So sometimes you're going to get some answers that aren't as nice as others. That's okay. Trust yourself. Even if this answer was wrong, a lot of teachers do give partial credit. They want to see, did you know to change this subtraction into a division with a single logarithm? Did you know how to use the definition to rewrite it? Did you know how to clear the fraction here with your rational? There are certain pieces that shows where your logic is. So if you got this far and you stopped, your issue isn't the math, it's your self-confidence. Okay? So be sure that you don't give up and rewrite it. At the very least, do it a second time, but don't erase it. That way you can take your homework or your test or your quiz back to your instructor and say, well, I did it twice and here's what I got. Can you show me what I did wrong? And that way you can learn from it. Okay, the very last one, we've got a natural log of 2x, which means you have an understood base of e. Remember, e is a number, not a variable. So you can use the definition, e to the power of 7 should equal 2x. Again, e to the power of 7 equals 2x. So to get the x by itself, you would divide both sides by 2. And so x equals e to the 7th divided by 2, and this is your exact answer. And you can always put it in your calculator and come up with the approximate if your teacher wants that. So how did you do? Well, remember a few things. First of all, we cannot get the variable alone if it's attached to the log or the ln. That's where the definition comes in handy. We need to get the logarithm by itself using the logarithm properties, which again are affiliated with the exponent properties. So think exponents. And we can use the definition to rewrite it without the log or the ln, the log or the natural log portion. Just a review of the definition, log base a of x equals c. If you take that base, take it to the power of c, it should equal your x. So a to the power of c equals x. And honestly, I still write this oftentimes when I'm doing work with students, the swirly do, or if I'm nervous or I'm tired. I'm like, oh yeah, okay, so here's my base, it equals that, it equals that. The more you do that, when you get to a test and you're nervous, your hand will be circling, doing the little swirly do before your brain catches up with it. So go ahead and write it with every problem so you don't forget. But notice this definition only works when you have one log. So don't forget to use your logarithm properties to rewrite it down to one log, then get rid of the log. Okay? So thanks for working. Yeah, thanks for working. Thanks for watching. Thanks for being here. Remember, if you have any questions, you can watch the video again. You can look for other videos. Ask your teacher, ask your tutors, ask your friends, but ask, okay? Don't let your pride keep you from passing. You're not alone. Hopefully, we'll see you soon.